Okay, 1.2, the rectangular coordinate system. For this section, we need to learn when and how the distance formula will be used. So first off, we need to know what the rectangular coordinate system is. We're going to start with drawing and labeling it. So the coordinate system is where we plot points and lines. So if you remember back from algebra, we have the two axes. The horizontal axis is the x-axis, and the vertical one is the y-axis. The four regions that the axes divide the plane into are called quadrants. We start labeling them in the upper right-hand corner. Now be quadrant 1. Then continue in a counterclockwise direction, labeling them 1, 2, 3, and 4. Note that we are using Roman numerals for it. So you should know the axes and the quadrants. Additionally, the point where the axes intersect is called the origin. And that is where we define each pair of coordinates. Now that we know the parts of the coordinate plane, let's go on to calculating the distance between 2 points in the plane. The distance formula is d equals the square root of x of 2 minus x of 1 squared plus y sub 2 minus y sub 1 squared. And what we're calculating is the distance between a pair of points. Remember that each point is an x and a y value. Since we have 2 points, that's why we have an x1 and an x2, a y1 and a y2. So in order to find the distance between those points, we just need to plug them in. Plug in our values in the right places. To help you plug them in, I'm going to put x1, y1 above my first set of coordinates, and x2, y2 above my second set of coordinates. So the distance formula is x2, which is 7, minus x1, which is 4. That quantity is squared, plus then y2 is 1, minus y1, which is 6, and that quantity is squared. Once we substitute in the values, and we can do the math. We'll take our differences. 7 minus 4 is 3. 1 minus 6 is negative 5. Be sure to put your numbers inside parentheses. It means something different. We do not have parentheses around this negative 5. Now we can square our values. So 3 squared will give us 9, plus negative 5 squared will give us 25. Whenever we square a number, we always get a positive result. Our next step will be adding. 9 plus 25 is 34. Now, the square root of 34, that is not a perfect square. So if we could, we would simplify it, but this one does not. As we have it written here, this is our exact answer. If we wanted to get an approximation, we could type it into a calculator. The square root of 34 is the way we will leave our answer for this unit. So that is our exact answer. Let's do one more problem. Here we're going to find the distance between the points 4, negative 2, and 3, 1. So I'll start by writing my formula first. So that's x of 2 minus x of 1 squared plus y sub 2 minus y sub 1 squared. Of course, that whole quantity we take the square root of. Okay, to plug in our numbers, we start with writing x1, y1 over my first set coordinates, and x2, y2 over my second set of coordinates. Ready to plug in. D equals the square root. X sub 2 is 3, minus x sub 1 is 4. And that quantity is squared. Plus y sub 2 is 1 minus y sub 1 is negative 2. I'll put that in its own set of parentheses. Now, when we go back through and do those subtractions, 3 minus 4 is going to give me negative 1, or negative 1 squared, plus. When I come over to do 1 minus negative 2, you should know that 1 minus negative 2 is the same as 1 plus 2. So that'll give me 3. And I have 3 squared. Now I need to square my numbers. Negative 1 squared. Remember, to square something means to take that number times itself. So negative 1 times negative 1 is positive 1. And my second number to square is 3. 3 squared is 9. I can add what's inside. 1 plus 9 is 10. So our answer is square root of 10. That is how we use the distance formula.